Okay, so today we're going to demo using the raster calculator in the spatial analysis toolbox to help us determine land use change in the city of Guelph, land cover change in the city of Guelph. Okay, so we learned about the raster calculator a while back now. We previewed that. And we learned that it was a way of putting together multiple raster layers. Okay, so when we have rasters that whose grids overlap, we can use the raster calculator to perform certain kinds of what's called map algebra. Okay, so we can add together cell values and produce a new layer representing the sum of those values. We can do multiplication, other kinds of arithmetic. We can also use the raster calculator not just for that arithmetic, but for looking at relational operators and logical operators. So using things like and, or, not. Okay, so not just doing math, but doing other kinds of logical operations on our raster data sets. So we're going to see that in a second, see what that means, and implement it technically. Let's set up our data here. So we are working with land cover data for the city of Guelph exclusively. And we have one layer that's from the year 2000. Okay, and you are going to be working with this data in Lab 5, so this is relevant. Okay, let's open up that attribute table. Okay, remember with our raster we have these integers representing different land covers, 21. If we look at the metadata, it tells us that represents urban areas, settlement. Okay, 41 happens to represent forests. Okay, and some other ones that we can look at the metadata and explore further. The key ones we're going to focus on today are 21 representing houses, generally built up areas, and 41 representing forests. Okay, so we can select these on our map. Okay, so no surprise there. There's all the urban areas in Guelph. 41, all the forests in Guelph. Probably what you expect. Though that is from 2000. Things have changed. The land cover in the city has changed, maybe not dramatically, but it has. So we have another raster layer that we're going to put on top of this one that represents land cover in 2010. Okay, so same resolution of that raster grid. The cells are all the same size, and we're using the same classification, the same integers to describe land cover categories. So when we turn this on, it's not a huge change. It's not like we decided to just blow up the city and, replace it with forests. Okay, land cover hasn't changed that much. But we do see, a bit of the expansion. We'll try it again. Bit of expansion in urban areas. Again, not unexpected. But, let's imagine that we are working for the city, undertaking a project for them where they want to know how many acres, how much land, forested land, has been converted over the past 10 years to urban areas. How much has urban development affected natural forest areas in the city boundaries? That is something we can use the raster calculator to determine. I mean, we can see visually that urban areas have expanded. We can guesstimate that, in areas where they may have overtaken forests, if we sit here long enough and turn this layer off and on, we can probably start to pick that out. But we have a tool in ArcMap to help us pull out specifically those raster cells where they were forested in 2000 and urban in 2010. Okay, so putting two layers together, not through and producing a new layer, not through arithmetic, not through addition or subtraction, multiplication, and so on, but logically. So we want to select the cells where the 2000 layer the cells from the 2000 layer that were forested, and the cells that in 2010 were urban. Okay, so let's find our raster calculator to implement that. So we use the search tool here. There are other ways of getting there, but the search tool will get us exactly what we need. Okay, so it's in the Spatial Analyst toolbox. All right, and so when this pops up, okay, we've got a number of different things to pick out here. So we have our layers or variables, and we have some numbers here. So if we wanted to, multiply, scale our raster values by a certain number for whatever reason, we certainly can do that. We have our arithmetic operators here. We have our relational operators here, less than, greater than. But then we also have logical operators. So equals, not equals, and these sorts of things. So we are going to go ahead and implement our expression to get us the places that were forested in 2000 and urban in 2010. Forested in 2000, urban in 2010. So I'll start with 2000. So we're going to say, take this layer, this raster layer. We want values equal to 41, which is forest, and we want this layer, 2010, we want those values to be equal to 21, or urban. Now, the raster calculator can be a little picky in terms of how it implements this expression, so we just need to put parentheses around each component of it. Okay, make sure you assign a safe space for your output raster so that you can find it later. This is fine for our purposes right now. And click OK. Okay, it's going to tell us it's working down here. And this is our result. So what the heck does this mean? Okay, the result is in Boolean terms. Okay, 0, 1, binary terms, yes or no. So these are answers to the question we asked, which was this, where are the cells that were forested in 2000 and urban in 2010? So when we get a 1, that's going to be a positive affirmative response, and a 0 is going to say negative. This cell was not forested in 2000 and urban in 2010. It may have been forested in 2000, but maybe it still is forested in 2010, or it's some other land cover. Okay, we are looking for cells that satisfy both conditions. Okay, and you can see that in the attribute table. Okay, so for the vast part of the city, we didn't see that change. We didn't see, cells, forests going to urban. Part of that's just because most of the city wasn't forested to begin with. But we see that 213 cells of forest were converted to urban development, and we can locate where they are. Okay, and we can do the math knowing that this is a 30 meter by 30 meter resolution raster. It just means every cell is 30 meters by 30 meters, or 900 square meters. We could do the math to find out how much actual area that accounts for. Okay, and we can also then style this in a certain way in order to make the changes more visible. We can overlay them on our other rasters in different ways. So this is something that you will actually be playing around with when you get to Lab 5. Okay, So this is a very garish color scheme for land cover. Okay, it looks something like out of a Nintendo video game from 20 years ago, 30 years ago. And your task in Lab 5 is not only to do a very similar kind of calculation, but to try to improve upon this design, and not just for Guelph, but for a city of your choosing. Okay, so now we've seen how the raster calculator works, and again, we will be exploring that further in Lab 5.